In this video, we are going to look at the properties of the graphs of quadratic functions. I have here a picture with three quadratic functions, a blue one, a green one, and an orange one. And something that they all have in common, and all the quadratic functions have in common, is that the shape that we have is called a parabola. So let me write over here, shape is a parabola. We have two kinds of parabolas. We have the happy ones that are smiling up, like in my picture over here. And we also have parabolas that are, we say, with a sad face, like the one I draw over there. So the blue and the green one would be examples of the happy or first type over here, and the orange one would be an example of the sad one. This that I'm drawing over here is what we call concavity. And we can say that the concavity is either positive, that's the happy looking one, or the concavity is negative, and that's a sad looking one. So here we have f and h are quadratic functions with positive concavity, and g is a quadratic function with negative concavity. And this is the first feature we are going to look at. The second feature we're going to look at is the y-intercept. So is the point where the parabola intercepts the y-axis. So for instance, in the blue one, we have the point over here. It looks it's more or less when y is equal to negative 1.5. For the green one, we have over here the point, it looks like 0.4 maybe. And for the orange one, it looks like the point is when y is equal to 2. So the y-intercept is, not intercepts, there is only one, is the value of the function when x is equal to 0. So it's a point 0 something else. And that's something that if 0 belongs to the domain of the function, we can always find. There is not because there are quadratic functions, like we can do this for any kind of functions. We are going to also look at the x-intercepts. And we're going to see later on that it could be that the function doesn't have any x-intercept, but in the pictures we have over here, our functions do have x-intercept, so they do intersect the x-axis. For instance, the blue one intersects the x-axis 2 times, once at -1 and once at 3. The orange one intersects the x-axis at -2 and at 1. And the green one just touches the axis or intersects it only at one point, this at when x is equal to 2. So the x-intercept, if there exist, are the points of the form something and then 0. So are points that are in the x-axis because the y-coordinate is 0. And this is something also that we may want to look at for any kind of functions, in particular for parabolas. The fourth of the features we are going to talk about is something that is special about parabolas, and is the fact that they have a point that is either a maximum or a minimum. They have a point that is called the vertex. So I'll change my color maybe here, and I'll show that what I'm talking about in the blue case is this red point over here, that is in this case the minimum point that the function reaches. So I'll write this point is called vertex, and it's either the maximum or minimum of the function. If the function is a function with negative concavity, then it's a maximum, and if the function is a function with positive concavity, then it's the minimum. I'm going to add that to the picture also for the other two functions we have. For the orange one, the maximum, so the vertex, is going to be more or less at, it looks from the picture, the x-coordinate is negative 0.5 and the y-coordinate like 1.42 maybe. And for the green one, the minimum point is the point that we also say was the x-intercept. So that's a vertex, and that's another important point. Another property of the vertex is that if we draw a vertical line going through the vertex, and then we try to fold the parabola with respect to that line, we'll get the two branches to coincide. So we have what we call the axis of symmetry. So this is number 5, axis of symmetry, and it's vertical line going through the vertex. So it's related to our point 4. So I can, for instance, here put a vertical line going through the red point for the blue one. So that will be my axis of symmetry. These are the 5 main features of the graphs of quadratic functions that we are going to work with. Let's see an example. We are going to be given a graph of a quadratic function in 1 second, and we want to find its 5 main features. So find the 5 main features of the graph of y equals f of x, and we're going to get the graph in 1 second. Let me just write here. The features are the concavity, the y-intercept, the x-intercept. Remember, there could be 2. The vertex and the axis of symmetry. So I have now just a blue function, so it's not so confusing. So first of all, we want to say whether the concavity is positive or negative, and we say it's a happy parabola, so the concavity is positive. Now we want to find what is the y-intercept. We say that this is the point where the function is crossing the y-axis, so the point is over here. So I'm going to write what the coordinates of that point are, at least approximately. The x-coordinate is 0, and the y-coordinate, it looks like, is negative 1.5. And I write here that this is approximate because I'm just getting this information from the picture. We do not know what this equation of the function, otherwise we'll be able to find it exactly. So this is just an approximation from the picture. For the x-intercepts, we have here one x-intercept going through negative 1, and another one is going to 3, and it looks like this is precise. So I'm going to write over here the coordinates of those points. Negative 1, 0 is one of the x-intercept, and the other one is 3, 0. We now need the coordinates of the vertex. That's a minimum point I'm marking over here. And again, it looks like we can say that this is exactly given by x-coordinate 1 and y-coordinate negative 2. Now the axis of symmetry is going to be a vertical line going through that point. So let me add a vertical line over here. I moved the picture, I didn't want to do that. Okay, back to its place, and now I can sketch the vertical line. Vertical lines have equation x equals to the x-coordinate of any of its points. So in this case is x equals 1 because we can see it over here. I'm going to add this information to the graph, at least the features 2 to 5. I'm going to show here that this is one x-intercept and the other one is here. I'm also going to show where the y-intercept is. This is the vertex. And here x equals 1 is the axis of symmetry. So I found the 5 main features of the graph and I added them also with small labels to the graph. And that's one of the exercises that you're going to have to do now.